Hello and welcome to this session about a career in big data analytics hosted by Dr. Sebastian Benoist, lecturer at the School of ICT at Griffith University. If you have any questions during this presentation, please type them in the chat box on your screen and Sebastian will answer these at the end. A link to a survey has also just gone into the chat, so if you could please complete this after the presentation, that would be much appreciated. Thank you for being here. I'll now pass over to Sebastian.
Hi everyone, it's a pleasure to be here. My name is Sebastian and I'm a lecturer in the School of ICT at Griffith University. I've joined Griffith University about a bit over 4 years ago and I'm working at the Gold Coast campus. I'll talk a little bit about my journey, how I actually got here, before we then talk a little bit about big data analytics and why big data analytics is important and why so many people in the news are talking about it at the moment. I probably have a little bit of an unconventional journey to get here. I was born in Germany, and so you may notice an accent, apologies for that one, and I finished my high school there. I then did an apprenticeship in a marketing agency because I actually wanted to get my hands dirty a little bit. After high school, I wanted to experience the working world and also earn a little bit of money, and so that's why I chose to do an apprenticeship first. Then I was fortunate to get a scholarship to go to the US for 1 year, and I actually worked and lived in Silicon Valley and got a job at Google, which was great, and I could see a little bit of the IT world in Silicon Valley, obviously. That kind of also created a little bit of a travel bug in me, and I worked in other countries like Portugal, Australia, and Indonesia before I went back to Germany to study, finally. And that was also a reason because I could get free education in Germany. I did my undergraduate studies in Germany in the area of business, not in IT, but in business actually. But I had a few classes in IT and I found that quite interesting. And I wanted to do a bit more of IT, but unfortunately I couldn't do that in Germany because it wasn't possible at the time. I was doing a combined bachelor and master degree that was called the Diplom back in Germany. And that was going for around 5 years. So it was a combination of bachelor and master together. And unfortunately, I couldn't do more IT back then in Germany. It was very difficult to switch. And then I looked back at Australia, and it was actually possible to do straight a master's after my undergraduate studies. So I switched to IT, and I did my master's in Australia at Griffith University. And overall, it was a great choice because I've been before living at the Gold Coast, and I found that Griffith had the best option for me in Australia to study in IT. After my master in IT, I started doing a PhD because I got offered a double scholarship from Griffith University, and I did my PhD in artificial intelligence. It's also quite a buzzword now, and there's actually quite a few things to artificial intelligence, and big data analytics is one part of it. And then shortly after my PhD finished, I was joining the School of ICT as an academic. And so this is why I'm here now for 4.5 years around. Now, let's have a little bit of a look at big data analytics because this is what you're interested in and why it is important. I've prepared a few slides, so let me just switch over to my slides here. So let me first unpack what actually big data analytics is. So you have the words big data in there and then analytics. Let's first talk a little bit about what big data is. It's a little bit tricky to describe because big data is something that's always changing. You have, for example, big data that we consider now big, that may not be big data again in a few years' time, let's say 5 years or 10 years' time. So it's kind of a definition difficult to come by because it's always changing. But there are 4 characteristics that are often used to describe big data. And these ones are shown here. So we can have a look at the top left, which says volume is one characteristic of big data. And that basically refers to that we have lots and lots of data that we are collecting and storing. And that is one part of big data. Another part of big data is on the bottom left, velocity. Not only do we collect lots of data at the moment, but also the speed at which this data is coming in to our systems is also very high. So if you think, for example, of a modern car, most modern cars have lots and lots of sensors in them. And all these sensors are always picking up all the time when you're driving input signals, and they're basically stored as data and analyzed as data to give you as the driver some information on what could be happening on the road. At the top right, you see variety. That's another characteristic of big data. It's not just that we have lots of big data and it's coming in at a fast pace, but also the data is very varied. So we have different forms of data. For example, YouTube videos, we have Twitter short text messages, we have lots of pictures that you post on Instagram, you have podcasts, all that different type of data is also something that we have to deal with. And then finally, on the bottom right is veracity, another characteristic of big data. And that refers to the uncertainty of data. If you think of the terms fake news that you may have heard, or fake reviews, or fake friends on Facebook, this is what veracity refers to. Just because we have lots and lots of information now with big data doesn't mean that that information or that data is always good data. There could be people maliciously typing wrong information and creating fake reviews, for example, and that is something that is making big data analytics very challenging. So that's the fourth characteristic. And those four characteristics are often mentioned to characterize big data. So now that you have a little bit of an idea of big data, what is analyzing big data? So what does big data analytics stand for? And I've put up here a few examples. Basically, analyzing big data refers to using computational algorithms to find some patterns and to get some outputs from these patterns, to find some information that is hidden in all this big amount of data. And if you think of Tesla here, shown as the car here, they are using lots and lots of data that is generated by the whole fleet of cars, and they're analyzing it with algorithms to make their cars drive without a driver, the self-driving cars, basically. That's their output of using and analyzing big data. And if you think of Tinder, the matchmaking platform, they're also using and analyzing big data to give you the next match. I mean, it sounds quite cold, but that's the truth. You also have H&M, the fashion chain, and they're also analyzing big data to find out what are the next fashion trends. So they're scrolling, they're crawling through the social media posts to find out what people could be interested in, what kind of trends are popping up from the influencers. On the bottom right, if you're familiar with this is Alexa from Amazon, and that's basically like a Google Assistant or Siri in your home. And you can speak to it, and it will do certain things that you ask it to do. For example, change your music or play a certain song. And Alexa is also collecting and analyzing huge amounts of data to be able to speak back to you and to do the operation that you asked it to do. So those are all examples where big data is being analyzed to create an output. And you can see it's quite varied, actually. So this already gives a little bit of an introduction to big data and big data analytics, but why is it important nowadays? Well, people have said that data is the new oil. You may have heard about this, and it's actually true because you can see that some of the biggest corporations in the world now are built on data. So you have, for example, Google, that you can ask Google anything that you want, and most likely Google will have some answer for you, because they've archived lots of addresses on the web and went through all this data to provide you answers. Apple is a little bit more of a hardware and software company, but they are also using big data to make their software, in particular Siri, better. Facebook, you probably know, is obviously a big data collector. And then you have Amazon and Microsoft, and they're making lots of money now with their cloud services platforms like Amazon AWS, you may have heard of it, where businesses can store their data and they're paying Amazon and Microsoft to do so. And if you look around your daily life as well, you can see that data is everywhere. So if you go for a run, for example, and you have your Fitbit or your fitness tracker on your wrist, you are generating data. And if you go to a hospital, you see lots and lots of monitors, and they're also all generating data. And even in the environment, we can put lots of sensors up to measure different things like temperature, humidity, etc. And we can use all this data to derive some conclusions, for example, about global warming. But something that you're probably more familiar with is the social media, all the different networks that you're using, Facebook, Twitter, Snapchat, etc. You're also contributing. Every time you put up a post, you're contributing to social media data, which is part of big data. And this is, at the moment, I would say, still the biggest slice of big data. We're generating lots and lots of information on these social media networks that contribute to the ever-growing big data that we have in the world. And it may change in the future. I think in the future we are going to get much more data from sensors that are deployed everywhere. So, for example, from cars, but also environmental sensors. But at the moment, I still think this is the largest chunk of big data. And that is also why at Griffith University, we are actually specializing in social media data analytics. You can see here myself, this was at the Open Day presentation in the left picture here on the left. And we're giving a little presentation on one of the research projects that my colleague is doing. We have a nice little curved screen, and you can see on that curved screen in our lab that there is a map, and the map has different roads. And the roads are highlighted in different colors. So this is basically a data visualization of what people have posted up as pictures. When they drive along that road, they take a photo, and we look at what the photo is showing. Is it showing more trees, or is it showing more buildings? Is there lots of traffic? And then the data was classified. And if there's, for example, lots of green to be seen in a photo, that goes along a certain road, then we highlight that road in green. And this is something that we visualized and shown here on the big curved screen in our big data analytics lab. Another thing that we do with social media analytics is gathering sentiment and opinions from people. And we have our Professor Bella Stantic, who was got a little bit famous when it came to the federal election, the last one, because he correctly predicted the outcome, where many of the traditional survey methods didn't get it correct. And so he actually received lots of inquiries from the media agencies. I think it was over 40 interviews that he gave on nationwide news media outlets. So that was quite a big success for our team. And that's also our focus in the course that I'm teaching, actually, on big data analytics and social media. That's a course that you usually take in the second or third year of your degree, if you do a degree with us in the School of ICT. What we do in that course is we look at real data from social media networks, and that includes Twitter and YouTube and Spotify. And we'll ask you to choose your favorite artist or band, and we'll let you analyze their social networks. And you can do something like find out where they have the most fans, something that you can see on the left-hand side. We'll do a visualization with the followers, or we could analyze what people are saying if they tweet about their favorite artist. So we're doing sentiment analysis that you can see here at the top right. For example, how many tweets express joy, sadness, anger, surprise, fear, or disgust. Obviously, you can do this by yourself a little bit if you just look at the tweets that you're interested in. But we use programmatic tools to do this automatically, and we do this on a very large scale. We also create networks that you can see here, for example, on the bottom right. This is the network around Donald Trump. So you can see what kind of relationships Donald Trump has on the social network, in this case, Twitter. So there's the First Lady of the United States, floaters, White House, etc., and other things. So these are quite nice things that you can do. And if you actually go out with this kind of skill set, not many people have this yet. And you can employ this social media analytics in many, many different careers. And employers will actually love you for it, because who would want to know, what are other people talking about their own brand? And even for yourself, it may be interesting, what are people saying about you if you have lots of followers? So this brings me to the end of this presentation. And let me just stop here. And I'd like to talk a little bit more about perhaps what may be interesting to you and what kind of high school subjects you could take in order to get into this kind of area. One of the interesting things that I should mention is that you can combine big data analytics with any other area. You've seen before, I mentioned Tesla. It's a car manufacturer. It's not just an IT organization, it's a car manufacturer where they're using big data analytics. There's also health, there's also the environment, and even if you're interested in languages, I'm actually doing a research project at the moment on text mining, where we have to look into linguistics in order to find solutions. So there are many different areas that you can combine with big data analytics. So if we look at high school subjects that you may be taking now, for big data analytics, obviously it would be any ICT subjects and perhaps mathematics. And then you can combine this with whatever area you're interested in. We also have some double degrees, and this ties in directly with these different areas where you can combine big data analytics. We have, for example, double degrees where you can study a Bachelor of Data Science, which is all around data analytics, plus a Bachelor of Business or a Bachelor of Science. So there are different combinations of double degrees where you can combine your favorite area, if it's not directly IT, with big data analytics. And that will really set you up well for a job later. Besides that, there's obviously a range of bachelor degrees in IT that we have at Griffith. And we'll have a little bit more information that we can give to you later on this one. Plus, we also have a range of scholarships that will support you while you're studying. Now, that will probably set you up well with a little bit of information up to your study, up to your degree. But what about after studying? And this is something I wanted to quickly talk about as well. After studying, you have mainly three options. Obviously, you have the option to go into the industry, get a job, and all students in our degrees are actually doing work integrated learning. It's a course that prepares you for the workplace. And we have some previous IT students that are now working at Amazon US and at Uber US, actually. So I think we can say we've got some really good programs that prepare you well for the workplace. So that was the first option. And most of the students go that way. Another option is also you can do more research if you want to pursue a PhD, for example. So if you're interested in research and want to know what's going on behind the scenes of the newest technology and perhaps the most progressive companies out there, then I'd suggest you look into doing a bit of research in a PhD, for example. And the third option is you could also become an entrepreneur and start your own business. And I must say, with a degree in IT, you have really good skills to start up your own business. Because in order to start your own business in IT, you don't need lots of material resources. You can use your own capital, which is your intellectual capital and your IT skills, to start a company. And I think that's a really good idea as well. And some students may be very interested in this one. I'm also mentioning this because I'm actually the director of the App Factory, which is a quite unique thing within Griffith and even within Australia. We have a student enterprise, which is called the App Factory, where students work on real projects. That could be their own idea, or it could be from a client, an idea. And what they're doing is they're building software apps in the broadest sense. Mobile apps, data analytics, data visualizations, games, or virtual and augmented reality. I'd say this is an excellent opportunity to boost your resume, network with potential employers, or get started to build your own business. I also have a unique opportunity for you actually today. There's a short course that I designed, and it is on the Future Learn platform. It's a big data online course offered by Griffith, and you can join anytime now until the end of June, and it's a free course, and it gives you a digital certificate. It's only a 2 weeks course with probably a weekly study of 4 hours. and it gives you an introduction to big data analytics, and it's a non-technical introduction. So you should be doing very well in this course without even having any programming experience. So this is an opportunity, and if you want to learn more about big data analytics, I think it's a very nice introduction. So I think now we are at the time where I can take some questions. So let me just bring up some of the questions that you may have. Okay, we have here a question from Anonymous. Does data analytics related jobs require a background or qualification with IT? That's a very good question. Yes, I like that one. So let me explain a little bit more about data analytics. I talk mostly about big data analytics, and big data analytics is part of data analytics in the broadest sense. There are certain degrees that look into data analytics as well. So for example, the business side, they also look into analytics, data analytics, but it will be different data. And most of the time, they will not really go into the big data arena because that is where you need programmatic tools. So you will need to know a little bit about programming and how computers work. So if you want to have the best stepping stone into a career in data analytics, I think it would be good to have a programmatic background. Then we have another question here. What has been your greatest achievement in your career so far? Excellent question as well. I would say my PhD journey was where I grew quite a bit. A PhD is a nice way of working because you really can dedicate your work towards one thing, and you have one big question, one big problem that you're trying to solve. But it is challenging because it's just you working on it. So you don't have teamwork, you're not working in groups with other students, so it's just by yourself. So you have to stay motivated, and you really have to be passionate about your research goal and work around it. But if there's something that you're interested in, I highly recommend it because it means you can have a few years' time where you really focus on honing your skills in solving that problem. Another question here, what are you most excited for in IT looking forward 3 years? This is also a very good question, and I'm glad that it's only asking for the next 3 years because IT is changing so quickly. In the next 3 years, definitely big data analytics is playing still a role in it. There is also another area that is quite interesting, which is called artificial intelligence. You probably have heard of these terms, and they're thrown around in the media a lot. I would say that actually to achieve artificial intelligence, there are many, many different paths to it. So if you think, for example, of a robot, like you see in the science fiction movies, with arms and legs and a head and stuff, there's different things to it. So you need to have, for a robot, for example, something like eyes. So a robot needs to be able to perceive the outside world. But then that will generate data. And then you need to analyze that data in order to make a decision. For example, should I go left or should I go right? So at the core, there will always be some data and it needs to be analyzed. And there are certain tools like machine learning, which you may have heard of, or data mining. They're all kind of related, and they may be applied on that data to give you the outcome that you want.
So that was the first question. Thank you for your presentation, Sebastian. And thank you for those that have joined today. Just another reminder about the feedback form if you haven't completed that already. And if you have any other questions, please visit the Griffith University website. Thank you very much.
Thank you, everyone.